Howdy and welcome back. So we're going to go ahead and get into the construction of our binary search tree objects. We're going to see a default constructor, which is going to essentially set up an empty binary search tree, and then we'll go ahead and see how we can implement a parameterized constructor that will take, say, some data, some key value, and create a binary search tree that's going to start out with a single node. And then we'll discuss in the next video some of the implications for that when we're defining our insert function. Because if we have the ability to have either to start out with an empty tree or a tree of some number of nodes, the insertion functionality that we're going to define the insert behavior is going to have to be designed in a way to accommodate both the empty tree as well as the tree that already has some nodes. So let's talk about default construction. This is going to be really simple. We're essentially going to have some root pointer that a binary search tree object is going to own, and it's going to point to, well, nothing, because we're not going to have a tree. So how do we set this up? Default constructor. This has to be defined as a class, or sorry, as a function template, because it is going to be scoped to our binary search tree of type T1, T2. So each instantiation of binary search tree is going to get its own definition of this function. Notice that in our parameter list, all we're doing here is initializing root to point to the null pointer, or to essentially take on the value null pointer. And then we're not going to do anything in the body of this function. Okay, cool. So let's now just take a look at our parameterized constructor. So this is going to need to have, some arguments that are going to be used to set up a tree with, in this instance, a single node at the root. So we're going to go ahead and pass in some data of type T1, and I'm going to go ahead and pass these by constant reference with the idea that when we go ahead and create a node with the data and key, a copy is going to happen. So it's not perform that operation twice. In addition to our data, we're going to see a second argument, second parameter in this case, key, and it's going to be a reference to an object of type T2. So whatever type was used to instantiate the T2 type parameter for some particular binary search tree object. Now we're going to go ahead and in the initializer list, point our root to the null pointer. And if you remember, the reason why we're doing that is we're not going to grab any memory within the initialization list. We're going to go ahead and just say root's pointing to nothing, and then we'll go ahead and grab that resource in the actual body of this function, with the idea that if for some reason we were not able to receive a new node object, and maybe there's some more complicated things kind of going on with the body, but it would at least give us an opportunity if, say, some sort of exception is being raised due to the acquisition of a resource. If we needed to, we'd have an opportunity to go ahead and clean it up. If, say, some sort of exception was thrown in the initializer list, we would never hit the body of this function and therefore would not be afforded with an opportunity to clean up any sort of mess we might have created before that exception happened. So I'm just being lazy here and I'm going to use auto. I know we haven't precisely defined what's happening there, but what we did say is we're going to let the compiler figure out what the type of auto is. In this case, temp is going to be a pointer to a node object of type T1, T2. And we're going to go ahead and allocate that out there somewhere on the free store. So temp's going to point to this new node. Let me try to make this out. Remember that the in-class initializers start out the parents as well as the left and right pointer to null pointer. So that's what we're looking at kind of in this configuration. And then whatever is going to be used to initialize the key value. And I'm going to go ahead and not show the data, but I don't know, we could think about this as, maybe data's over here underneath. I don't know the best way to visualize this, but yeah, that object will have some sort of data. But for our discussions here, we're just going to focus on the key because that's what's going to be important when we're going ahead and inserting an object, a node object into a pre-existing tree. But we don't have to worry about that here because we're building up a brand new object, which means that there's no possibility this tree could already have any nodes within it because it's not constructed till the end of the constructor. So we're going to go ahead and copy over data into our nodes data field, and then we'll go ahead and initialize key with the key passed as an argument to this function's key parameter. Finally, the last thing we have to do, we've created a node, we've built it up, we've configured it as we've wanted. We need to go ahead and point the root to this newly allocated and configured object. So at this point, remember, we don't have to go ahead and update any sort of pointers really, because remember what's special about the root node, it's not going to have a parent. So this is totally cool right there. The parent field pointing to the null pointer or storing the null pointer. If we go ahead and look at, say, the left and right fields, well, this is a tree of a single node, so it can't possibly have any children yet. We haven't inserted any additional records into our binary search tree. We'll do that with the insert function. But right now we've gone ahead and we've have a single parameterized constructor, which takes two arguments of type T1 and type 2 for data and the key respectively. We could have configured, any number of parameterized constructors for our binary search tree. For instance, maybe we wanted to have a vector of data and key that we'd go ahead and use to build out a whole tree. Well, we're not going to worry about that right now, but that might be something for you to think about. And if we also had some other behaviors, we could definitely utilize those within our constructor. So it could be as simple as creating a root node and then just using some sort of insert operator that maybe we'll define in the next video to go ahead and build up a tree so that by the end of the parameterized constructor, you could have a full-blown binary search tree if you wanted. And by full-blown, I mean more than one node. So anyways, we're just keeping it simple here to run through the motions. So we've went through our default construction of an empty tree, and the only parameterized construction we'll be going through together here is going to be to create a tree of a single node residing at the root. So let's go ahead and make this a bit more interesting and get into, well, how do we build up a tree? Well, we're going to define an insert function. And remember, if we're inserting records into our binary search tree, we're going to want to do so in a manner that satisfies the binary search tree property.